Let's try to connect MicroSUM to the PC and discover some configurable features on the DAK software. As seen with the other data loggers, we open DAK and go to Tools, then Target, and select MicroSUM. The software will ask us to restart. We confirm, and DAK will restart in a mode compatible with MicroSUM. The connection to the PC is made via a micro USB cable. Once connected, we open the Windows Device Manager and identify the assigned COM port. In our case, the system recognizes it as COM4. We go back to DAK, go to Setup, select COM4 port, and use the Execute Station ID function. Request to verify the connection. If the data logger responds, we can start configuring. MicroSUM uses a single configuration file, unlike other models that use separate files. We go to File, New, to create a new configuration. We will find a simple and intuitive tree structure. Let's start with parameters. Right-click, Insert Identity. Here we can assign a name to the station. Then we add a serial channel to define the use of the serial ports. MicroSUM has 3, identified as COM1, COM2, and COM3. We also add a modem channel, specifying the type of SIM and the operator's APN. It is possible to activate a debug channel, useful for outputting diagnostic messages on a serial port in real time. In the parameters, measurement offsets can also be set, for example, for level sensors. We insert a parameter, initialized to 0, with units of measurement in centimeters. Now let's move on to the acquisitions section. We can configure a serial sensor as a Modbus or SDI12. We assign a name. We define how many seconds to sample, process, and store the data. We also set a minimum validity threshold, for example, 50. The standard processing mask option is used to specify if we want to store the average, minimum, maximum, etc. For example, to record average, minimum, and maximum, we enter the value 14. If the sensor supports Modbus, we enter the device address and the register number to read. It is also possible to enable pre-activation, for example by setting 5. The sensor activates 5 seconds before the sampling, optimizing consumption. We can also set alarm thresholds with minimum, maximum, and hysteresis values directly within the measurement. Let's now go to the transmission section. We enter an FTP transmission. We define the sending frequency under normal conditions, for example every half hour, and we can set a faster frequency if there is an alarm measurement. In the FTP configuration we enter name of the transmission, data format, usually record, server address, port, username and password, file prefix, and the path if you wish to save the data in a specific directory. MicroSUM also supports satellite transmissions, which can be configured similarly and can be programmed to send data in formats compatible with proprietary or compressed protocols. We have thus completed a basic configuration for MicroSUM, from the connection to the PC to the acquisition and transmission of data. For more detailed information on advanced features and supported protocols, it is recommended to consult the complete technical manual available on the manufacturer's website.